So hello everyone, welcome back to the channel. In today's video we will be discussing about an interesting topic. So let me ask you a question. As we all know that in a right angle triangle we have three sides, which is this side from here to here. This is termed as perpendicular. We say this side base and this side as hypotenuse. Okay. There are three sides named perpendicular, base and hypotenuse in a right angle triangle. So this is a right angle triangle named A, B and C. So we all know that in a right angle triangle we have perpendicular. This side is known as base and this is known as hypotenuse. What if I ask you that is there any kind of relation between perpendicular, base and the hypotenuse of this right angle triangle? So the question is that if I give you the measurement of perpendicular, the measurement of base, so can you calculate from these two information the measurement of hypotenuse? Is there any way to calculate it? Is there any formula? So the answer is yes, there is a formula with the help of which we can calculate the third side of a right angle triangle by using the two sides. So what's that formula? So in today's topic we are going to learn about that formula, and that formula is known as Pythagoras. So according to the Pythagoras theorem, we have the hypotenuse square is equal to square of the perpendicular plus square of the base. This is the formula that we were talking about. With the help of this formula, you can calculate any third side if the two sides are given. Suppose if you have been provided with perpendicular and base, then you can calculate hypotenuse. Or you are given with hypotenuse and perpendicular, then you can calculate base. Or if you are given with hypotenuse and base, then you can calculate perpendicular. So this formula helps us to find third unknown side if the measurement of two sides are given. So the Pythagoras theorem says that the square of the hypotenuse is equal to the square of the perpendicular plus square of the base. So suppose if you are given that in a right angle triangle the perpendicular is equal to 4 centimeter and say base is equal to 3 centimeter, then if I ask you what would be its hypotenuse, then from this formula you can easily calculate the measurement of the hypotenuse. How? You have to just write the formula h square is equal to p square plus b square, and you can also write it as, if you remove a square from here, you will get square root on the right hand side. And now you can easily calculate by putting the value of perpendicular and base. So p square, here we have p is equal to 4, which means 4 square plus we have b is equal to 3, hence 3 square here. From here we can we will get 16 plus 9, which will be equal to under root 25, and finally we will get 5 centimeter. So the hypotenuse here will be equal to 5 centimeter. Similarly, if you have been provided with perpendicular and hypotenuse, then you will be able to calculate base also. How? You from this formula h square is equal to p square plus b square, you can easily derive b square is equal to h square minus p square, and hence b is equal to under root h square minus p square. So from this formula you can calculate the base of the right angle triangle if perpendicular and hypotenuse is given. Similarly, for the perpendicular also you can derive the formula. So this was all about the theoretical aspects of the formula of this Pythagoras theorem. Now let's discuss the visual aspect of this formula. Okay, look, here we are trying to visualize the Pythagoras theorem. What does Pythagoras theorem says? Pythagoras theorem says that if there is a right angle triangle and if this is P, which means perpendicular, and this is base and this is hypotenuse, then we can write h square is equal to P square plus B square. Okay, this is what Pythagoras theorem states. Here we have a square in orange color and a triangle in blue color. So with the help of this square and this triangle, we will try to visualize this Pythagoras theorem. Okay, let's put this triangle over here on the square like this. Again take a right angle triangle of the same dimensions and put it like this. So cool. We have here a bigger square, name it ABCD. Okay, A, B, C and D, and inside the square we have there 4 right angle triangle, 1, 2, 3 and 4, and we have a square in the middle. Now let's try to find out the dimension, or say the measurement of the side of this bigger square, that is ABCD. So as we all know, this is a right angle triangle which is equivalent to this right angle triangle. So this side from here to here which will be equal to B. Okay, and this side here will be equal to H, since this is the hypotenuse. Similarly this will also be equal to H. Similarly this will also be equal to H, and this line will also be equal to H. So this orange square here, what will be the area of this orange square? Okay, let's write the name of the vertex, P, Q, R and S. Okay, if I ask you what will be the area of P, Q, R and S, what will be the area of PQRS? Here you can see that PQRS is a square, okay, with side H, and this H is actually the hypotenuse of this right angle triangle. If you compare this right angle triangle from this, you will conclude that this side is equal to H. So what about the area of PQRS? It will be equal to H into H, and we can write it as H square also. So the area of this orange square PQRS here, it will be equal to H square. Okay, cool. Let me ask you a question. What if I shift these right angle triangles inside the square? We'll not take these right angle triangles outside of the square, but what we will be doing here is just try to shift it inside the square like this. So what we have done here? Here we have just shifted the triangles, right angle triangles, inside the boundary of this square. Okay. Now what about these two, this square and this square? What will be the area of this square? What if I say you that the area of these two squares taken together will be equal to this H square? Will you agree with me? Okay, let me clear you. What we have done here, we have just shifted the right angle triangles inside the square. So the vacant area before will be equal to the vacant area after shifting the triangles. So the vacant area, the empty area is not going to change. Okay, initially we have the empty area in the middle, which was the PQRS. In this case we have empty area, this and this. So however, the orientation of the triangles are changing, but if we talk about the area of the empty space, that will remain constant. So what can we say? That we can say that the area of this shape and the area of this shape will be equal to h square. Okay, let's name it. Let's name this area as area 1 and this is area 2. So we can write here that area of figure 1 plus area of figure 2, and this will be equal to the previous vacant area, which was equal to the h square here. Okay, cool. Now let me ask you, what will be the area of the figure 1? What will be the area of this figure 1? So as we can see here, this is a square. Okay, if somehow we are able to find the side of this square, that is from here to here, if somehow we are able to find the side of this square, then we can write its area. So what will be the side of this particular square? So the side of this particular square will be equal to this side. And what is this side? This side is basically the perpendicular of the square, equal to this side. Okay, so the area of the figure 2 will be equal to p square. It will be equal to p square. Similarly, if we look at the first figure here, what will be the area of this square? So if we try to find out the side of this square, we can conclude that the side will be equal to the p, this base. Okay, so we can easily say that the area of this first figure will be equal to b square. Now put the values in the equation that we have here, and we can write that area of 1, which is equal to b square, plus area of figure 2, which is equal to p square. This will be equal to h square, and we can rearrange it as follows: h square is equal to p square plus b square. So this is the formula or say theorem which is known as Pythagoras theorem, that we have just proved visually with the help of a square and triangle and a right angle triangle. So that was all about Pythagoras theorem, and I hope you have got the concept. So thank you for watching the video.